Coplanar force. So the definition of the coplanar force is a group of forces in which all forces lie in the same plane. Okay, this is same plane. So in the coordinate geometry, uh, three dimension can represent the all space. Like there are one dimension is just like one directions, and two dimension will be a plane, and three dimension will be the space. For example, let's talk a little bit about that coordinate geometry. So you can visualize your room, your table surface, and uh, this surface. Let me make another. This area where z equals to 0, and this is xy plane. Similarly, pink area is xg plane, and purple is xy plane, and green will be yz plane. The plane is represented by the two coordinates. In the uh, definition of the coplanar force, the force must be in the same plane, either in xy, xg, or yz plane. And we can combine this force using any vector combination or vector algebra. In the example, you can see one mass, 500 kg, is suspended by two force, two string, T1 and T2, and this force direction, this one, yeah, this. And there are three forces, T1, T2, and T3, and they lie in the same plane. For example, this direction is X, and vertical direction is Y, and this all three forces lie in XY plane, right? This XY plane, and this is known as the uh, coplanar force, and all three forces meet on a single point, this one, and this type of coplanar force is known as concurrent coplanar. There are other type of the coplanar force in which force lie in the same plane, but they do not meet each other at a single point. For example, in the seesaw, uh, two forces are acting down. Uh, so this is weight force F, force F1, force F2. Another force is acting this one, which is reactions, force acting up. So we have three forces, but they do not meet each other. They are in also the XY plane, and they are also parallel. And this type of force is called non-concurrent coplanar force. Okay, now component of coplanar force. We know that the in coplanar force exists in the plane, right? This is x direction and this is y direction. Suppose we are acting with three forces here. One force is acting this direction, it's F3. Two forces acting this direction. We are pulling this ball, F2 and 1. So these all forces have x and y component. So what is the x component of force F? F3 x component, f2x component, f1x component, and similarly y component we have respective 3 y component, and to force f3 has no y component. Maybe we can make 0 here. f2 has y component, right? This directions, and f1 is also y component acting this directions. So f2y, f1y. We can sum over the force along the one directions. For example, fx is the sum of the force like in x directions. f1x plus f2x plus f3x. This can be written as like this one. 1, 2, 3 f I x in summation form. Similarly, f y equals to summation I to 1 to 3 f I y. So in this way we calculate the component of individual coplanar force in different directions.